To emphasize this dual loss of kinetic energy, I have compared Einstein's relativity using the Lorentz formula with LIGO-Virgo's discovery of the velocity of gravity equal to the maximum speed of light. For Einstein's relativity, as the objects descend, the rate of acceleration increases. The rate of acceleration decreases as the velocity increases. It is as if some of the kinetic energy is converted into time dilation. Meanwhile, during the ascent, the rate of deceleration increases as the velocity decreases. It is as if the time dilation is transferred back into kinetic energy. This is because the ascending values, although different than Newtonian numbers, are symmetric with the ascending values. However, when the velocity of gravity is reduced to the maximum speed of light, the ascending and descending comparisons are asymmetrical. The descending perceived distance is larger than the ascending perceived distance. This means that the descending acceleration, which is change of velocity over change in time, is less than the ascending acceleration. This asymmetry continues down to both the energy and the change in energy values. Many learned men are emphatic about the conservation of energy, how it cannot be violated, and so they attribute this loss of energy to multiple things. The most recognized is creation of a gravity wave, but as I mentioned earlier, a gravity wave always exists. It's just that at infinite velocity, it is difficult to perceive the instantaneous gravity wave. Note, the energy isn't used to create the gravity wave, but rather a finite gravity velocity alters the perceived location of the others to a previous time. If the other's object is approaching, it appears further than it is, and if it's receding, then it appears closer than it is. Consequently, the attraction is asymmetric. Less acceleration when approaching and greater deceleration when receding. The law of conservation is not supported. "350 years ago, Ole Romer had proved that the velocity of light was not instantaneous, but had finite speed. Consequently, when observing a moving object, we observed them where it was in the past. At that time, no one had bothered to consider if the same would be true to gravity. The delay in gravity would mean that objects would gravitationally perceive other objects where they were located, not where they were observed, not where they were actually located. Referencing GW 1509-14, if gravity was instantaneous, then the two objects of a binary system A and B would visually and gravitationally perceive each other where they are. For a circular orbit, the attractive force between them would be perpendicular to their velocities, resulting in a never-ending orbiting of two objects, not allowing for mass transfer, rotational inertia, radiation emission, or a third object. With a finite gravitational wave, A would perceive B at its previous location B prime, while B, likewise, would perceive A at its previous location A prime. While this makes an imperceptible change in length, it does change the angle of the distance vector, meaning that instead of having the force being perpendicular to the velocity, the forces are now permanently at an acute angle to the velocity. This is the equivalent of perpetually being in the lactose rectum descending point of an elliptical orbit with no chance of arriving at the periapsis. Each object is losing potential energy and gaining insufficient kinetic energy in return. causing it to spiral downward in an ever-increasing velocity, resulting in the famous chirp. And this is what we observe with every gravitational wave that has been discovered. To conclude, energy is not converted into gravitational wave because even when the velocity of gravity is infinite, the gravity wave exists. The slowing of the gravity wave to a finite speed is what causes the change to the distance vector, either by length or direction, to the other object. This changes the force, either by strength or direction, which changes the acceleration, which changes the velocity, which changes the kinetic energy. This loss of energy, both coming and going, demonstrates that the law of conservation of energy is actually an approximation. Science is the systematic pursuit of knowledge and understanding through evidence, observation, and testing. As such, everything must be falsifiable. Nothing can be uplifted to a status of unquestioning acceptance. This is the definition of blind faith. Past laws have been demoted to equations that are valid under certain circumstances. And here's a brief history. In 1619, Kepler published his law of planetary motion. 57 years later, Ole-Romer proved that gravity had finite speed. In 1687, Newton published his law of universal gravitation, demoting Kepler's planetary motion from an unquestionable law to a set of equations valid for a two-body system where the primary mass is over 1,000 times greater than the secondary mass. William Rankine coined the term law of conservation of energy in 1850, based on speeds that were never approaching anywhere near half of 1%. Albert Einstein's relativity theories, they finally figured out not to call new discoveries laws, of 1905 demoted Newton's law to a set of equations valid only when the object has a velocity of under 4.47% the maximum speed of light, when the Lorentz time dilation is less than 1.001. Einstein also coined the term fabric of space-time, implying that there was only a single fabric, where the time rate of an object is dependent on the speed of the object. And most recently, in 2017, the teams of LIGO-Virgo confirmed that gravity also travels at the maximum speed of light, reducing the conservation of energy to an approximation, valid only when the observed objects travel at speeds under 3.14% the maximum speed of light. While light is slowed by gravity, demonstrated by general relativity, which will be a different set of video series, the effects of gravity are not. Gravity travels at a constant velocity at the maximum speed of light. Contrary, whereas Einstein implied that space-time was a single fabric, it turns out that space-time is multi-fabric. Every object has its own perspective, depending on its own velocity, and must be taken into account by outside observers. Did I mention that mass does not increase with velocity? Unlike observed distance to high-speed objects are dependent on the object's velocity. Fast objects coming towards an observer appear further than they truly are, while fast objects moving away from an observer appear closer than they truly are. Meanwhile, fast objects traveling laterally may have little change in the length of their distance. Their vector component is delayed, resulting in the perceived angle lagging behind the actual angle. My name is Richard, and this is my defense for the reduction of the first law of thermodynamics, namely the law of conservation of energy, to an approximation only valid when the velocities observed are much, much less than the maximum speed of light.